In this video, we're going to evaluate the integral from 0 to pi of cin of x, where cin of x is a cosine integral, which is the integral from 0 to x of 1 minus cosine t over t dt. I'll be referring to this special function as just the cosine integral. Also, don't forget to subscribe and turn notifications so you don't miss a video. Okay, the first method is to replace the cosine integral with the definition, which is the integral from 0 to x of 1 minus cosine t over t dt. Okay, so now let's look at the graph. So we're going to have a t-axis, which is usually the y-axis, and x-axis. So x will be from 0 to pi, so that's where we're going to position it. T, which is usually y, is from 0 to x, so it would be from t equals 0 to t equals x. So t equals 0 is right here now, and t equals x will be this line, and it'll connect to make this triangle area, which, now what t point is this? So it's t equals x, so the last point is t equals pi. Okay, so the area goes from 0, so t goes from 0 to x, so t goes from 0 to x like this, so up arrow, so it's this triangle area. Another way to look at it is looking at x from left to right. So x will go from x equals t to x equals pi. So this is x equals t. Okay. And we're going to go over from t equals 0 to t equals pi because it'll be on t equals x line. Okay, so the other integral is from t to pi, right, of 1 minus cosine t over t dx dt, so we're swapping the coordinates. Now notice this is not with respect to t, so we can take it out. But we can also look at this, the integral from t to pi of 1, which is just the upper endpoint minus the lower endpoint. So this will be the integral from 0 to pi, 1 minus cosine t over t, we can take out, and then, as I said, the integral of 1 is just the upper minus the lower, so pi minus t dt. Okay, good. So now we can take the pi, put to the front, so this would be pi integral from 0 to pi of 1 minus cosine t over t dt minus the integral from 0 to pi. Okay, t over t will cancel, so that would just be 1 minus cosine t dt. Good. What is this? So this is really interesting. That is the cosine function evaluated at x equals pi. This would be pi times the cosine function at pi minus. Okay, so now we're going to integrate 1 minus cosine t from 0 to pi. So this will be t minus the integral of cosine t is sine t, plugging in from 0 to pi. Like 0 will go in, and sine of 0 is also 0, so this goes away. Sine of pi is 0, so this will just be pi, cosine integral of pi minus pi. So that is the first method. The second method, just keep it in the same integral, but now let's look. Now we're going to differentiate both sides with respect. Okay, I wrote it wrong, but it's with respect to x. Sorry. Okay. Yeah, you can't have t goes from 0 to t. Okay, so this will be the derivative of the cosine function of with respect to x equals the derivative with respect to x of this. So you just put the x into this function, which is 1 minus cosine x over x. Okay, so now we're going to do the di method. So we can look at this as the cosine function of x times 1. The integral of the cosine integral times 1. So this will be ci of x, and this will be 1 minus cosine x all over x. Then we have plus minus, and we integrate 1, which is x, cross them, and then this will be an integral, so this will be x ci of x from 0 to pi minus the integral from 0 to pi. Okay, x over x will cancel, leaving us with 1 minus cosine of x dx. Okay, let's look at this for a second. So integral from 0 to pi of 1 minus cosine x. Let's not do extra work. This is the same thing as this integral, which we found out is pi. Okay, so we'll just use that result so we don't have to do more work. So this will be, let's plug in the lower bound first. So 0 times anything is 0. So we're just going to plug it in the upper bound, so minus nothing. So that'd be pi ci of pi minus, and then we know that this is just pi. So that is the second method. And of course it agrees with the first method's answer. And that's the end of the video. Hope you liked it.